this video is for Math 112 trigonometry, and this is for the sample midterm exam. So let's see here. The last page in the sample midterm is the formula sheet, and I'll provide the same formula sheet for you on the midterm exam. So it's got the sine ratio, the cosine ratio, and the tangent ratio defined, and then it's also got information about the x-axis and the y-axis when you're graphing a sine or cosine function. Let's see here. Well, I think that's about it, so we'll go ahead and get started. The test itself is 6 questions. There's 3 word problems and 3 graphs. So let's take a look at the word problems. Problem 1. We've got a helicopter hovering over the ocean. Yeah, so there's 2 ships here. There's that. This height is 3,200 feet. Let's see here. This angle of depression here is 42 degrees, which means this angle is also 42 degrees. And then this angle of depression is 21 degrees, which means that this angle in here is also 21 degrees. Okay. Let's see. Altitude is 3,200 feet. Find the distance between the 2 ships. So here's the thing, is that we can label this side x and this side y, and we can say tangent of 42 degrees is 3,200 over y, and the tangent of 21 degrees is 3,200 over x. Okay. So then we'll multiply on both sides by y and divide on both sides by the tangent of 42 degrees, and we'll get y is 3,200 divided by the tangent of 42 degrees. This marker's not going to last a long time, so I've got another one. All right, let's see here. 3,200 divided by the tangent of 42 degrees, and let's double check, make sure I'm in degrees. Yep, okay, good. So that is, let's see, we're rounding to the nearest foot, so I'll carry over a decimal point or 2 and then round at the end. This comes out to be about 3,553.96. And then the other one, let's see here. We're going to do that same process. Let's create some separation here. There we go. And again, we're going to multiply on both sides by x and divide on both sides by the tangent of 21 degrees. So those cancel, and x is 3,200 divided by the tangent of 21 degrees. Let's get a good approximation for that. 3,200 divided by the tangent of 21 degrees. 8,336.28. 8,336.28. And then we want to add on the 3,553.96, and that comes out to 11,890. 890 feet. Okay, well, I'm going to give up on the black marker, and I will use the red one. Alright, so that's problem 1. Relatively straightforward. Really all you had to do was a little bit of calculation and then add those 2 sides together. Alright, problem 2. All right, problem 2, we've got this mountain that we want to build a tunnel through. So the diagram looks something like this. There's the mountain. We've got an angle of elevation here of 47 degrees. Now there's the height for the mountain, is inside the middle of it, okay? Let's see here. And then over on this side, the angle of elevation is 36 degrees. Right? Oh, and the mountain is 260 feet high, so there's our 260 feet. Okay, and we've got information that this piece right here is 150 feet, and this piece over here is 200 feet. So, let's see, I'll call this piece X and this piece Y. Okay, because they're in different triangles, and so that's why it's useful to assign different variables to them. Okay. All right, let's see here. So in the end, what we're looking for is x plus y, which is the length of the tunnel, and we want to approximate that to the nearest foot. So this has some similarities to problem number 1. We're going to set it up with a tangent function. The tangent of 47 degrees is 260 over this whole side, right? You've got to get the whole side in the right triangle, so that's y plus 150. On the other side, we've got the tangent of 36 degrees is going to be 260 over x plus 200. Okay. So that'll get us started. Now to solve for these variables, we want to get them out from the denominator, so we're going to multiply here on both sides by y plus 150. Those will cancel. Let's see here. Maybe I'll do an approximation for the tangent of 47 degrees. There's a variety of things that you can do to solve this. Let's see, 1.07237. 1.07237, y plus 150 equals 260. And then we're going to multiply that times 150. 160.855 over here, 260. So let's subtract this on both sides. So what is that going to give us? It's going to give us a little less than 100, right? 260 minus 160.855, 99.145. And then over here, 1.07237y. So divide on both sides by 1.07237. And what do we get? 1.07237. 92.45, we'll call it. 92.45. Okay, so there's part of what we want to know, which is this distance right here. And then we'll go through the same process to find x. Multiply on both sides by x plus 200. So 260 is going to be, let's see here, tangent 36 degrees, 0.72654. 72654x plus, there we go, 145.31. Okay, so subtract that on both sides. 114.69. And over here, 0.72654x. And so divide on both sides by 0.72654, and we get x is approximately 157.86. Add that on to the 92.45, and that comes out to be about 250 to the nearest foot, 250 feet. Okay. So there's problem 2. So those first 2 problems are pretty straightforward. This one, I think there was maybe a little bit more to do than in the first one. Problem 3. Problem 3 is one of those problems where we're going to have to make a substitution. Okay. Pretty straightforward. There's not a whole lot of description or, context to this problem. You've got a flagpole with 2 measurements. Here's 48 degrees. Here's 32 degrees. We know that this distance between those 2 points is 36 feet. And we want to know how high is the flagpole. So I'll call that H and I'll call that X. Alright, so then we can say tangent 48 degrees is H over X. And we can also say tangent of 32 degrees is H over X plus 36. That's not degrees, that's feet. There we go. Okay. All right. Well, what do we want to do here? I'll multiply on both sides by X and say H is X times the tangent of 48 degrees. And so then I'll put that in up there and say tangent 32 is X times the tangent of 48 divided by X plus 36. Okay, so let's clear out the denominator. Multiply on both sides by X plus 36. So now I've got that X tangent 48 isolated. And here we'll get, let's see, let's approximate these tangents. So, tangent 32 degrees, 0.62487. 487x, and then multiply that by 36, 22.495. Okay. Oh, and then on this side, we want to get tangent 48 degrees with a good approximation, 1.1106, we'll call it. And then over here, 62487x and 22.495. So let's subtract. Let's get these x's together. Those cancel out. This is 22.495. Over here, we're going to subtract 0.62487. And what do we get here? 0.48574. Something along those lines. I subtracted it from the non-rounded off version of the number, so these values aren't quite coming out to be the same. Let's see, 0.48573. Yeah, so if we work from this value here and this value here, then that would be a 3. Okay. That wouldn't throw our answer off too much, but it is good to keep things correct. So 22.495 divided by 0.48573. 46.312. And then we know that the h is x times the tangent of 48 degrees, so let's multiply by the tangent of 48 degrees, and we get h here is going to be about 51. Oh, right, so we want to round this to the nearest inch. 51.4344. So it's going to be 51 feet, and then take that .4344, multiply it by 12, and we get about a little bit over 5 inches. And there we go, 51 feet, 5 inches. Okay, so those are the sample application problems. The problems you see on the actual midterm will be a little bit different, but you can be sure that you'll have one like this where you need to make a substitution, right? Where you've got these two nested right triangles. It's a very common thing. This is a common way that people measure the height of something. They take one measurement, back up, take a second measurement, and then you can calculate the height of the object. All right, so now let's look at the graphing problems. There's going to be 3 of those as well. Let's see what we've got. And again, you do have that information about how A, B, C, and D affect the x-axis and the y-axis. Okay, and so I'm not going to write the whole thing out, but the x-axis is affected by B and C, and the y-axis is affected by A and D. Okay, so let's see here. Problem 4. Y equals 2 minus 5 sine a half x. All right. So I'll start with the y-axis because that's usually the more straightforward piece of this problem. We've got a vertical shift here. The value of D is positive 2, so that's going to be our midline value. Our amplitude here is 5, and so this will go, maximum will go up 5 points to 7 and down 5 points to -3. Okay? Now notice that there's no value for C, so that means that there's no shift. We'll be starting at 0. But the period is going to be a little bit different here. The period is going to be 2 pi divided by a half, which is 4 pi. Okay? So we're starting at 0, we're ending at 4 pi. That means cut this in half, this is 2 pi, cut this in half, that's 1 pi. Okay? You can also do that thing that I was talking about in section 2.5. Take 1/4 times the period, and then that'll be the value for each one of these jumps. Start at 0, 1 pi, 2 pi, 3 pi, 4 pi, and that's how it's happening. Let's see, this is a negative sine graph, so we'll start at 0 and then go down to the minimum first, back to 0, and up to the maximum before you come back to 0 like that. Okay, so that's problem 4. Notice, like I said, I try not to just jam-pack these full of all of the transformations on every problem, right? In each problem, I try to kind of get at a little bit different part of the concepts. So there's problem 4, and so that focused, I think, mainly on the y-axis. Then you had a little change in the period, but no phase shift. Okay, problem 5. What do we have here? Y equals cosine 2x plus pi over 3 plus 3. Okay. So again, let's see, we've got a vertical shift of 3. So that means our midline value will be 3, but our amplitude is just 1, and so it'll go up to 4 and go down to 2. So we've got an amplitude of 1. Let's see, our phase shift, the new starting point, if we set this equal to 0, and then divide on both sides by 2, negative pi over 6 is our new starting point. Okay. All right. Now the period is 2 pi over b, which is 2. So the period is pi. So each of these jumps, right here is going to be 1/4 of the period, or pi over 4. Okay. All right. So we're starting at negative pi over 6, and we want to jump pi over 4 each time. Looks like we need to turn these into 12ths. Negative 2 pi over 12 plus 3 pi over 12, right? This gets multiplied by 3 over 3. That one gets multiplied by 2 over 2. Gives us common denominators of 12. All right, so now this will be positive pi over 12. And then you can just keep adding this 3 pi over 12 on there. So that's going to be 4 pi over 12, 7 pi over 12, 10 pi over 12, and 13 pi over 12. And again, we can go ahead and do the actual addition. There's our 4 pi over 12. And there's the 7 pi over 12. And the 10 pi over 12. And then the last one, 13 pi over 12. So then we've got the starting point, pi over 6. 1, 2, 3, 4, 5. Looks like I went one place too far, so we don't need that 13 pi over 12. Let's see. So this is negative pi over 6, positive pi over 12. This is pi over 3, 7 pi over 12, and then this last one, 5 pi over 6. Okay. So let's go ahead and put those in here. There we go. Pi over 12, pi over 3, 7 pi over 12, 5 pi over 6. Positive cosine graph, so we'll start up at the maximum, pass through 0, minimum, 0, maximum. And I say 0, but of course it's the midline value, which is 3. All right, so there's that cosine graph for number 5. And again, you can see this one was pretty heavy on the phase shift, right, together with the period, but nothing too tricky along the y-axis. All right, one more problem to look at. Problem 6. Y equals 2 sine x minus pi over 4. Okay. So notice in this one, we've got a phase shift and a change in the amplitude, but the period is going to stay 2 pi, and there's no vertical shift at all. Okay, so that means that this will start at 0. The maximum there will be 2. The minimum will be negative 2. Our phase shift is going to be pi over 4, right? We're going to start our new starting point will be positive pi over 4. Right? And our period is going to be 2 pi. And so each of these jumps is going to be pi over 2, which is 2 pi over 4. Right? So this is going to go 1 pi over 4, add this on, this will be 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. Okay? And that all comes from taking the starting point, pi over 4, adding on 1/4 of the period, which is pi over 2, and then we make a common denominator for them of 4, 2 pi over 4. So there's our second point, 3 pi over 4, and then do it again. The third point is 5 pi over 4, add it on again, 7 pi over 4, and then the last one, 9 pi over 4. Okay, all right. So we've got the x-axis all set up, we've got the y-axis all set up. It's a positive sine graph, so we start at 0, which this time really is 0, go up to the maximum, back to 0, down to the minimum, and back to 0. Okay, so that's it. 6 questions, 3 application problems, 3 graphs to draw. I talked about the formula sheet. So that's pretty much it. If you have any questions on this, please let me know. And best of luck. I'll see you next week.